Materials engineers study the structure, processing, properties, and performance of stuff, or what we like to call materials. Materials are divided into four major classes: metals, ceramics, polymers, and electronic materials, and we study how these classes fundamentally differ so that they can be applied to appropriate applications. And because these applications are really too numerous to count, materials engineering is everywhere, even if you've never heard of it. For instance, the aerospace industry needs alloys with high strength-to-weight ratios to optimize rocket fuel consumption, and the automotive industry needs to reduce weight in vehicles to increase fuel economy. The biomedical industry needs biocompatible materials that won't be painfully rejected by the body. Even the chemical industry is trying to find the next Teflon, or nylon, or Kevlar. The list goes on, but materials engineers get to take a crack at that list.
As materials engineering students, we take all of the general engineering classes: calculus, physics, statics, and chemistry. We also take general material science classes and thermodynamics to give a good overview of the field. We also take a course in each class of materials: metals, polymers, ceramics, and electronic materials. Some of our upper level classes include failure analysis, materials characterization, and metals processing. We also get to do tons of hands-on lab work, including generating a phase diagram, heat treating steel to get different microstructures, using a superconductor to levitate a magnet, and learning how to use X-ray diffraction and scanning electron microscopes.
My name is Grant Bogus. I'm going to be a rising fifth year in the materials engineering program. I was originally from Lexington, Kentucky. I graduated from Dunbar High School.
Hi, I'm Alec Kimis, and I'm a senior here at UK and from Louisville, Kentucky.
I'm Ujan. I'm a fifth year materials student, and I'm from Metro Detroit, Michigan.
My name is Hannah Frankel. I am a senior at the University of Kentucky, and I'm from Danville, Kentucky.
I chose UK because it had always been in my backyard, and I actually got a chance to come down to UK my senior year and work in a research lab down here. And I loved the atmosphere of how welcome they were to having undergrads getting involved in research, and how that transitioned into a lot of other opportunities that came along with that.
So I actually came to Lexington when I visited, my official visit during school was when we won the 2012 National Championship, and the school spirit was so awesome and I wanted to be a part of it, so I picked UK right then and there.
I picked materials because I had a really great conversation with the head of our department, Dr. Volk, and I was very interested in his research.
I picked materials because it applies to so many different fields. So coming in as an undeclared engineer, I really wasn't sure what was going to be my passion. and I wasn't sure whether it was going to be energy, biomedical, or more like industrial management, but materials definitely applied to all those different fields because they're intertwined in every single company.
One of my favorite MSc memories, because I have many, is when I volunteered for Engineering Day. So Material Advantage had a setup for Engineering Day where we put on a bunch of demos for students around middle school, high school age to look at and see material science in the works. And so the demo I worked with this last time was with superconductors. So essentially with superconductor material and liquid nitrogen, we were able to make a magnet kind of float. And it's really, really neat to see all these kids' faces just kind of like light up in excitement and amazement at our material science. And so it's definitely a fun time.
My favorite MSc memory is definitely the day that we threw our professor a birthday party in lab. We celebrated Dr. Koshell's 28th, 29th, or 30th birthday, but he would not tell us the actual day.
I would like to go to grad school to pursue a PhD and hopefully work on high entropy alloys.
What I'm planning to do after graduating is going out into the workforce and finding a job in industry. Preferably, maybe, I'm minoring in biomedical engineering, so I've considered maybe looking for a company that works with biomedical devices or tools or biomaterials or some sort. But what's really important to me is to find a job that I will, whether it's research and development or process manufacturing, I'm kind of interested in doing either or, as long as that whatever I do will be able to impact and change lives of other people. That's what's most important to me.